Alright guys, welcome back. Tonight we're going to go over Lewis dot structures using an Ion chart. We'll cover molecular geometry, orbital geometry, hybridization, axe notation. Also, don't forget to check us out on YouTube, username WhitwellHigh, or our website at whitwellhigh.com. Alright guys, let's go ahead and get started. Before we get started, you're going to need a couple of handouts. One of the handouts you're going to need is a periodic table. Now you can get this periodic table off of my website. Okay, just go to Johnny Cantrell on the chemistry page. Okay, the next thing that you're going to need is handout 6A. Handout 6A covers the geometries, the axe notations, bond angles, how to draw them, all those things. So you'll need this handout as well. Plus it tells you if it's polar or nonpolar. Now, let's go ahead and get started. What we're going to draw tonight is we're going to draw let me maximize the screen. We're going to draw the ammonium ion. Now, the ammonium ion has this for its formula, NH4 with a positive 1 charge. This problem's different because it's got a positive 1. So let's go ahead and get started on our Ion chart. E, A, and N. Now, E will be our elements. A will be our valence electron count, which means available electrons. N will be our need amount. Okay, so we've got elements nitrogen. We've got 4 hydrogens. Make sure you write down all 4. It's best practice if you do. On this last one, I'm going to write the word charge. This is just where I put it in my Ion chart. Okay, now go ahead and draw your grids. Now let's get the numbers. Now, nitrogen has 5 valence electrons. So let me show you how I know that. I can show you on the periodic table. Let me pull it up real quick. Nitrogen is in column 15. Here it is. You see it? Column 15. So that's 5 valence electrons because it's in column 15. Just ignore the 1 in front of the 15. So that's 5. So it's got 5 valence electrons. So let's record that. If you notice back at hydrogen at the periodic table, notice that hydrogen has 1 valence electron. So make sure that you put 1 down. Now the charge, if the charge is plus 1 here, write negative 1 here. You always write the opposite. If that had been plus 3, you'd write minus 3. Here's the reason. It has to be 1 less electron because it has a positive 1 charge. So there's the 1 less. Okay. Now the need amount, if it's the first 5 elements, lithium, beryllium, boron, hydrogen, and helium, if it's those, then they get 2. But notice that nitrogen was not in that group of 5. So therefore, it's going to need 8. Remember, the need amount is 2 or 8. Hydrogen, of course, would get 2. Now, the word charge gets none. It doesn't need any. It's a charge. Anyway, we add this up. We'll get available equals 8 because 5 plus 1 plus 1 plus 1 plus 1 is 9. Minus 1 is 8. Now, the need amount, 2, 4, 6, 8 plus 8 is 16. Okay, to get the number of shared, you subtract these 2, so the shared amount, 16 minus 8 is 8. Number of bonds, half of 8 is, guess what? You're correct, half of 8 is 4. Now, the last thing we need to do is get the number of non-bonding electrons. This is the only one that's kind of weird. Non-bonding electrons is A minus S. I'll write that one down for you. A minus S. So basically, we have 8 minus 8, which is, you guessed it, 0. So the number of non-bonding electrons is 0. Now let's go ahead and draw this, see if we can. Central atom here would be nitrogen because we've only got 1 of those. It's got 4 substituents, so let's go ahead and attach those 4 around the central atom, north, east, south, west. North, south, east, and west. So we write our 4 hydrogens. Now you're almost done. But we have no dots to put because NBEs were 0. We used our 4 bonds. But it is a polyatomic ion, meaning it is an ion, so it's a charge, so we've got to put brackets around it. And outside the bracket in the top right hand corner, we'll write the charge again, plus 1. Now it's okay if you write just plus or 1 plus. Technically you should write 1 plus, but this is the mathematician in me. Now let's go ahead and get the last bit of information. We need to get the orbital geometry. Okay, to get that you will need that second handout that I was telling you about, handout 6A from the website. That is this handout. Okay, now the orbital geometry, how do we find that? Well, if you notice back earlier on the problem that we worked, we found out that we had no loose electrons running around. Here we had 4 bonds, so there's no lone pairs here, and there's 4 bonds. So notice here on this sheet that we have 4 0 right here, 4 bonds and 0 lone pairs. Okay, so that tells us that our orbital geometry is, well, tetrahedral. So make sure you write tetrahedral down for your orbital geometry. Okay, now the molecular geometry, let's get it off the chart as well. Look at 4 0 right here. Okay, the molecular geometry is also tetrahedral, so make sure you write that down. Okay, the next thing that we need to get is hybridization. Okay, hybridization. What is the hybridization of this? Well, look at 4 0. All the way down through here. Hybridization, hybridization. Oh, there it is, hybridization. SP3. Okay, let me show you how they get SP3. I never really look at the chart, but I was showing you the chart. This is the way I was taught. Count from one of these bonds and just work your way around. So let's call this S. Then this is SP1, this is SP2, and SP3. So that's why that's SP3. Now you also do this if you had a set of lone pairs. Like if this was a lone pair, that'd be S, SP1, SP2, SP3. You still would count it as a lone pair. Okay, so there's the hybridization. The next one is the ax notation. Well, on this sheet it tells you the ax notation. The ax notation is AX4. Now let me explain to you what happened to the E. We had no lone pairs, okay, because this number was 0. Since that's a 4, then that's a 4. But you don't have to write the E at all. There's no sense in writing E0. I guess if you did, it wouldn't be wrong, but I always just tell my students not to write it. Alright, and finally, the last thing we need to figure out if it's polar or nonpolar. Okay, to do this, look back at the sheet. Okay, on this handout, if you'll notice that things that are lightly grayed are nonpolar. Okay, so that's pretty straightforward then. So we know that our problem that we have is nonpolar. Okay, so you'll write down nonpolar. Now, so that's what I've done here. I wrote nonpolar. Now I will show you something neat about the nonpolar. If you're looking at the chart, you'll notice that anything that's grayed lightly is nonpolar, but if you also notice, these nonpolar guys have a number with a 0, number with a 0, number with a 0, until you start getting down towards the bottom. Now, the exceptions are the 2, 3, the 4, 2, and the 2, 4. Now, if you look closely, I always tell my students the exceptions for these are the ones that's like our area code. Our area code where we live is 423. Look at this. 4223. And then all you got to do remember is that the 42 is flipped once, 24. So there you go. Well, I hope that was helpful walking you through this. Here's the problem one more time. The ammonium ion written out. The number of non-bonding electrons, 4 bonds, nonpolar, AX4, hybridization SP3, molecular geometry tetrahedral, and orbital geometry. I think I said molecular geometry. Molecular geometry tetrahedral and orbital geometry tetrahedral. So just don't forget to put your ion in brackets and throw the charge to the top right, and you should be good to go, guys. Well, now just for the credits. Now, I used Ubuntu 9.10 to make this video, and I hope you enjoyed it, and I hope it helps you. Alright guys, y'all have a good night.